So there's one type of trigonometry problem that almost every student gets wrong, and it's probably not the one you're thinking of. I'm going to show you what it is, exactly why people get it wrong, and most importantly, how you can get it right every single time. We're going to skip the fluff and get right into mastering trig applications and avoiding those simple traps that cost you marks. Okay, look at this question. If cosine of x is 5/13, what's tangent of x? Now, if your brain immediately screams, grab a calculator, find the inverse cosine of 5/13 to get the angle x, stop. Just stop right there. That's the long way, and it's a path full of potential errors. There is a much cleaner, much faster way to do this. And this is exactly what I'm talking about. This is the detour that so many people take. You find the inverse cosine, you get this long, messy decimal for the angle, and then you try to find the tangent of that decimal. It's an extra step, it introduces rounding errors, and honestly, it just wastes time in an exam. We can bypass this whole mess completely. So before we jump into the right way to solve that problem, let's do a quick pre-flight check. We need to make sure our essential mathematical toolkit is sharp and ready to go. And here it is, the absolute classic. SOH CAH TOA. You have to know this like the back of your hand. Sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. As per the NCERT curriculum, this is the bedrock. Everything, and I mean everything we're about to do, comes back to these three fundamental ratios. All right, here's the elegant, efficient method. Step 1, just sketch a quick right-angle triangle. Step 2, label what you know. Since cos of x is adjacent over hypotenuse, we'll label the side adjacent to our angle x as 5 and the hypotenuse as 13. Step 3, find that missing side using Pythagoras. So we've got 13 squared, that's 169, minus 5 squared, which is 25. That leaves us with 144. And the square root of 144? That's 12. So our opposite side is 12. And now the final, easy step, calculate tan x. Tangent is just opposite over adjacent. That's 12 over 5. Done. No calculator, no decimals, no errors. Just a clean, direct answer. Okay, perfect. Now that we've sharpened our skills on a pure ratio problem, let's take these tools and apply them to one of the most classic real-world applications of trigonometry, figuring out heights and distances that you just can't measure with a ruler. So here's a very typical exam question. You're standing on top of a cliff. You look down at a boat, and the angle of depression, the angle you're looking down at, is 35 degrees. We know the boat is 120 meters away from the bottom of the cliff. The question is, how high is that cliff? This 4-step blueprint is your key to solving these every single time. 1, draw the diagram. This is non-negotiable, and it's the most important step. Label everything you know. 2, from your angle's point of view, identify the sides. The height of the cliff is opposite the angle, and that 120-meter distance is adjacent to it. 3, choose your ratio. Well, we have opposite and adjacent. That immediately tells us we're using TOA, or tangent. 4, set up and solve the equation. Tan of 35 degrees equals the height divided by 120. A quick multiplication, and you've got your answer. And this right here, this shows the number one mistake people make. The angle of depression is measured from a horizontal line looking down. A lot of students will incorrectly stick that 35 degrees inside the triangle at the very top. The trick is to remember your geometry. Alternate interior angles are equal. So the angle of depression from the cliff is the exact same as the angle of elevation from the boat. That's the 35-degree angle you use inside your triangle. Get the diagram right, and you are literally halfway there. Now, let's switch gears a bit. It's not always the geometry or the diagram that trips you up. Sometimes the problem is pure algebra, and there are some really common traps that will absolutely cost you marks if you're not careful. Take a look at this one. If sine of 25 degrees equals cosine of the quantity y plus 50 degrees, find the value of y. Now, at first glance, this might look really intimidating. How in the world are you supposed to solve for y when it's locked inside a cosine function like that? Okay, first things first, let's talk about what not to do. This is the big trap. You cannot, I'll say it again, you cannot distribute a trig function across a sum. Cosine of y plus 50 is absolutely not the same thing as cos of y plus cos of 50. That's a fundamental misunderstanding of how functions work, and it's a guaranteed path to the wrong answer. The secret here isn't some fancy algebra. It's a simple, powerful trigonometric identity. And this is a core concept right out of the NCERT syllabus.
Sine of an angle equals the cosine of another angle if and only if those two angles are complementary, which is just a fancy way of saying they add up to 90 degrees. This is the rule that unlocks the whole problem.
So let's apply it. We have sine of 25 equals cos of y plus 50. Based on our rule, we know that the two angles 25 and y plus 50 have to add up to 90. So we just write that equation. 25 plus y plus 50 equals 90. This simplifies down to 75 plus y equals 90. A quick subtraction, and boom, y equals 15. See how that works? It goes from being a really tricky-looking trigonometry problem to a super simple one-step algebra equation. All right, let's wrap this all up. I want to give you a quick mental checklist. Think of this as something you run through for every single trigonometry problem you solve. It's designed to help you catch those silly mistakes before they happen. Just ask yourself these 5 simple questions. 1. Is my diagram actually clear and labeled correctly? 2. Are my sides, opposite, adjacent, hypotenuse, labeled right from the perspective of the angle I'm using? This is huge. 3. Did I pick the right tool for the job, the correct SOH CAH ratio? 4. Did I double-check my algebra at the end? And 5, the sanity check. Does my answer even make sense? You know, if you calculate the height of a person and you get 500 feet, you've probably made a mistake somewhere. This simple check will save you so many marks. So here's your final assignment. Go find your last math test. Look for a trig problem or you lost marks. Now, which of these traps was it? Did you draw the diagram wrong? Did you pick the wrong ratio? Was it a simple algebraic slip? Find it. Pinpointing your own personal pattern of mistakes is the absolute fastest way to get better.